Okay, hello students, and welcome back to another session of our online class. In today's class, we'll be discussing on network strategies. As you all know, in our previous class, we've discussed on network topology and network topology. If I go briefly on that, right, it says, right, so network architecture is divided into two parts, which is topology and strategy. So topology is something that we've already discussed in our last class, and it basically describes how our network is configured and arranged, and strategies that we will discuss today. It define how resources are shared. Now there are the six types of different types: bus, ring, star, tree, hybrid, and mesh. Now bus network. In this type of network, each device in the network handles its own communication. There is no host. All this we have discussed, and then this is the setup, right? And then the advantage and disadvantage we looked at. Then ring network, we have looked at the setup, how information is passed. We have looked at the diagram, right? And then the advantage and disadvantage. Also the star network, similar for tree network, hybrid network, and mesh network. We have looked at the features, the advantage, and the disadvantage. Right now, in today's class, we discuss network studies. So let me start. It says a network strategy describes how resources and information is coordinated and shared. The most common network strategies are terminal, client server, peer-to-peer, and distributed. So we will discuss on these four network strategies in detail, and how information is shared, right? How resources is shared within these different types of network strategies. We'll be looking at. Now, first one, terminal network. In terminal network, processing power is centralized in one large computer, that is the server, which can handle a large number of connections. All nodes connected to the server are either terminals with no little processing power or microcomputers running special terminal emulation such as Windows Remote Desktop. In terminal network, that means there is a server, there is a large computer which is a server, and everything is done by the server. Okay? The other computers, the other terminals which are connected to the server has little or no processing power. Okay? So all the processing part is done by the server in terminal network. This is how a terminal network looks like. So you can see the server is there, okay? And all the four computers that are here is connected to the server. So these connected computers are the client computers, and it is accessing everything from the server. All the processing is done in the server, not in here. Okay? So that's what terminal network does. Now, if you look at the example, okay? For example, most airline reservation systems are terminal server networks. The server maintains all airlines schedules, including rates, seat availability, bookings, and or flight arrival or departures. Travel agents use terminals to connect to the server to make reservations. Although the tickets may be printed along with travel itineraries, the agent's desk, nearly all processing is done by the server. So that's how, for example, that's what is done in airline reservation system, where there are terminal server networks. All the processing is done by the main server. Right? The main server is all the information. Right? What is the price of the ticket? How many tickets are available? Right? They are available. Right? All the booking and the flight arrival departure information is in the SEVA. And that SEVA is connected to many terminals. Right? The travel agents are using that terminal to connect to the SEVA. Right? Even you are able to make online booking. Right? Straight from your home, you can make online booking. Now, that website that we will be using to make online booking, that is connected to the SEVA, the terminal to the SEVA. Right? So the number of seats available um, will be able to know which seats are available. Right? Why? Because you are the end user. You have no processing power. All the processing will be done by the SEVA. Right? You are only connected to the SEVA from your local computer. Right? The advantages. Yeah, there's one advantage of terminal network, which is centralized location and the control of technical personnel, software, and data. Disadvantage: lack of control and flexibility for the end user. Terminal systems do not use the processing power available with microcomputers. So, advantage is that everything is centralized, meaning all the work is done by the SEVA. So, the other computers which are connected to the SEVA has no control, right, of the technical personnel and the software and the data. Disadvantage is a lack of control. So lack of control is another disadvantage. Is a disadvantage because end users may want to do something else, something more, right? But just because they don't have access, they don't uh, processing power, then won't be able to control it. And the temperature do not use the processing power available with microcomputers. Next one, the second type of network strategy is client server network. Now, in client server network, the host computer usually the server coordinates resources to other computers connected to it. The software running on the client requests for information and services from the server, which then responds to individual clients. Right? In a network, the client server model provides a convenient way to interconnect programs that are distributed efficiently across multiple locations. So, what happens in the client server? There's a server, right? And then everything is stored in the server. Now, if the client computer, the computers are connected to the server. Right? If they want to request any information, they'll, they'll just ask the server, and then the server will provide them. Services and other things, everything is done by the server. Only thing the client has to request. Now, for example, rather than saving a lot of things, multiple files in different computers, it's better to have one server, and then in that server you can put all the files, all the necessary files, and what you can do, you can connect all your computers to the server. It will be easier. The files will be at a central place in one place, and then you all will be able to access. Okay? Not the hard disk space in your computer, in your personal computer, or in your client computer will not be used. Why? Because you are just connecting to the server. Okay, the resources. You are not saving any file in your computer. Because everything is saved in the server. You are just connecting and viewing things from the resources that are available in the server. Now, this is how a client server network looks like. You can see a server is there, a main server, and that server is connected to the router. Okay, the router, why it's connected to the router? So that internet connection is there. Right? Another connection is backup. So everything that is here in the server is backed up in one drive, and then printer is there. So since printer is connected to the server, all these computers can connect to the printer. Why? because this seva is sharing resources and information to these computers. Okay? Now, these computers, since it is sharing resources and other things from the server, it is also sharing the printer, also sharing the internet connection. Right? So all these things are able to connect to the internet, connect to the printer. Now there is a wireless access point also, so it will boost the network. Okay? Wireless access point will boost whatever network is provided by the router. It will boost it so that it reaches greater distance, and then since it reaches a greater distance, the wireless devices will also be able to access the internet. So that's how client server network looks like. Example is just computer transactions using the client server mode are very common. For example, to check your bank account from your computer, a client force a request to a server program at the bank, and then that program may intend for forward the request to its own client program that sends a request to a database server at another bank computer and to retrieve your account balance. So that's how there's a procedure to check your account balance. Okay? You are using your maybe your mobile phone or maybe your laptop or maybe your computer at home to open, for example, BSP online banking. So you're logged in and then you requested to see the balance, the transaction, the things. So you are using a client computer, right? Inside there, using a client program. A program that is designed for clients. Okay? So once you request, and then that one is forwarded to the server. The server program in the bank will then forward the request to its own client program that sends a request to the database server at another end to retrieve the account balance. So that's how it works. And that's how client server network works. See, the balance is returned to the bank account client, which in turn saves it back to the client in your personal computer, which displays the information to you. Now, advantage is its ability to handle very large networks efficiently. See, so client server network is a very efficient network. Right? It can handle very large networks, right? And then powerful network management software controls the network's activities. So it uses a very good network management software. Right? So network activity is also monitored through client server model. And then disadvantage, the cost of installation and maintenance. So always, if something is something has a lot of advantages, so definitely the disadvantage will be the cost. Right? Installation and maintenance of the client server model is very costly. Next one, the third one is peer-to-peer network. Nodes have equal processing capabilities and can act as both the client and the server. So in peer-to-peer, the computers are connected to each other, and every computer can act as a client and also act as a server. It is a type of transient internet network that allows a group of computer users with the same networking program to connect directly access files from one another's hard drives. So this is how peer-to-peer network looks like, and you can see every computer is connected to each other. So if one computer wants resources from another computer, for example, this computer wants resources from this computer. So what will happen? This computer will become a client because it is asking for resources. This will become act as a server because it will provide resources. Okay? Or it can be the other way around. This one is asking resources from here. Okay? So this will be the client and this will be act as a server. Similarly for other computers. Now, Lamway and Freenet are examples of this kind of peer-to-peer software. Major processors, producers of content, including record companies, have concern about what they consider illegal sharing of copyrighted content by suing some peer-to-peer users. Meanwhile, corporations are looking at the advantages of using peer-to-peer as a way for employees to share files without the expense involved in maintaining a centralized server, and as a way for businesses to exchange information with each other directly. Advantage: it is cheap and easy to install. Right? Inexpensive means cheap. It works well for smaller systems with fewer than 100 nodes. That means less than 100 computers. If it is there, then it peer-to-peer network works very well. A disadvantage is the number of nodes increase, meaning if number of computers increase in the network, the performance of the network declines. So peer-to-peer network best is works best when there are few computers, that is less than 100 nodes, and it is very cheap and very easy to install. Now, last one, fourth one, is distributed processing network. The processing capability is shared across multiple nodes, usually servers displayed at different locations. That means there'll be one main server, and then from that main server there'll be other servers which will be linked to it, and then other servers will be at different places, right? And those servers will also provide services to the clients that will be there, right? So one main server, and from one main server there'll be it will link another two servers, right? And then those servers that are linked, not too many, and then those servers will link other client computers. So let's see. This study is common for a very large organizations like banking industries. So you can see there's a big server, right? So this big server is connecting four computers here, right? Maybe these four computers are just at the same place, same location that this server is, right? Now this main server is connecting two more servers, right? Meaning these two small servers are inheriting information from the main server, right? Now this server is connected to this computer, this server is connected to this computer. Okay? So why distributed processing is used? Distributed processing is used because uh, because we have to share information at a longer distance. Example, it says banking industry. Okay? So that example is here. Okay? For example, INZ Bank has its main server in Melbourne, Australia. Right? So INZ is a Australia New Zealand bank. Main server is in Melbourne, Australia. But for Fiji customers, INZ House has its own server that does the processing for its Fiji customer. So the another server is in Suva, right? In the INZ house, right? And that server and that is in Suva. It is also linked to the server that is there in Australia. See, so mine server is in Australia, and that one is linked to the server. Maybe there is a server in New Zealand, so it is the main server is also linked to that server. Okay, and then it says the account details are then replicated to the main headquarters servers in Melbourne. So everything is done in Fiji, different branches in Perth, Tavua, Rikiriki, and so on, right? And all the processing is done in the main server, which is in Suva. Right now, after all the processing is done, then whatever information is stored in the server, that server is that information replicated, meaning copies of all the information is made and sent to the server that is in Australia. So that is called distributed presence network. Okay? Right here we have more than one server. Main server and the other ones are the servers which are inheriting information from the main server. Now, in advantage, there is improved sharing, improved availability. Users at one side can access data stored at the other side. Data can be placed at the site close to the users who normally use the data. Disadvantage: increased complexity, cost, and security issues. Data integrity can be difficult. So, as you see, it's very easy to share, but this disadvantage, and it is available. Users at one side can access data stored at other sites. So you can access from bar, and the server is in Suva. Okay, so all those things, all those are the advantages. Disadvantage, yes, there will be disadvantages. There will be increase in complexity and cost and security issues. Just because it is linked, right? One server is linked to another server is linked to the third server. Since many servers are linked and it is at a distance, security issues are there. And then data integrity can be difficult, meaning you will not be able to combine data. Okay? Sometimes it will be difficult. Right? If you are replicating data, physics data, and putting in Melbourne's database, then there can be issues. Okay? So those are the disadvantages. Note: you cannot have a network setup without either of the network type, topology, and strategy. Meaning, to have a network setup, you have to have a network type. Network type, remember I have discussed about that. Some of the network types are LAN, MAN, WAN, PAN, WLAN, and so on. And you should have no topology. Topology are bus network, star topology, bus topology, star topology, ring topology, mesh, hybrid, right? And maybe I missed one or two, right? So those are the topologies. And strategy, today I discussed about it. It is client server strategy, peer-to-peer strategy, distributed network, right? And the fourth one was just one I discussed, terminal network, right? So those are the four network strategy I have discussed, right? So in order to have a network setup, you need to have all these things, right? If one is not implemented correctly, the entire network will collapse. So when designing networks, you must first describe the network type to be used, and finally the strategy. In most cases, the topology in the replica says which strategy and type is appropriate for a particular setup. So choosing the topology first helps. So it's better to choose the topology first, and then when you describe the network type, then the topology, and then the strategy. Now I have a short video for you people to see, so that you better understand whatever our discussion was about. And this video is just showing the difference between client server architecture and peer-to-peer architecture. Please watch it properly, carefully, right? And
computer network architecture. A computer network architecture refers to the way how computers are organized in a network. It defines how the computers should be connected to get the maximum advantages of a computer network, such as better response time, security, scalability, etc. The two most important computer network architectures are peer-to-peer architecture and client-server architecture. Peer-to-peer architecture. In peer-to-peer architecture, all the computers in a computer network are connected with every computer in the network. There is no central computer that acts as a server. Every computer have equal status. Advantages of a peer-to-peer architecture. less costly as there is no central server. If one computer in the network stops working, all other computers in the network are not affected, and they will continue to work as same as before. Installation of peer-to-peer architecture is quite easy. Disadvantages of a peer-to-peer architecture. Each computer in the network has to take the backup separately, and the security measures are to be taken by all the computers separately. Scalability is a problem in a peer-to-peer architecture, as connecting each computer to every computer is a headache on a very large network. Client-server architecture. In client-server architecture, a central computer acts as a server, and serves all the requests from client computers. All the shared data is stored in the server, which is shared with the client computers when a request is made by the client computers. All the communication between the client computers take place through the server. Advantages of client-server architecture. Data backup is easy, and less cost, as there is no need to manage the backup on each computer. Performance is better, because the server is more powerful than the other computers in the network. Security is better, as unauthorized access are denied by server, and all the data goes to the client computer through the server. Scalability is not an issue in this architecture, as large number of computers can be connected with server. Disadvantages of client-server architecture. In case of server failure, entire network is down. Server maintenance cost is high, as the server is the main component in this architecture. Cost is high, as the server needs more resources to handle.
Alright, thank you very much for watching the video. If you have, I hope you have understood, right, and the network strategies. If you have any questions regarding to this, please feel free to send me a message on Viber or on Messenger, and please keep on doing the answering the worksheets and send me the solution so that I can mark and give you feedback. So I'll leave you people with this, and hope to see you people in our next class. Thank you.